Welcome to Defen, episode number 53, 4?
54,
something?
I think it is.
54? Yeah, okay, 54. Yeah. Wow, I think we took a kind of a small summer break, hiatus, and then we're back. But this time we're back with a bang with Mr. Dave Yarwood, all the way from the US of A.
Hey, thanks for having me.
Whereabouts in the US are you, Dave?
I'm right outside of Durham, North Carolina. Actually, right now I'm at the office of AdZerk, where I work, which is in downtown Durham.
Right. You're in the kind of the blast zone of Clojure.
Yeah, it's like Clojure HQ.
Yeah. Talking of the heart of Clojure, maybe we should start by just talking about the fact that we all kind of met up at the heart of Clojure while you were over there. I think you gave a lightning talk, didn't you, Dave?
Yeah, so I'm very grateful that AdZerk pays for us to attend some conferences every now and then. And I heard that Heart of Clojure was happening. I was like, what if I attended a European Clojure conference? And they're like, yeah, okay. All right, Dave, you can do that. So it was really awesome.
Yeah, it's really good. Yeah.
Well, it was a really nice demo. So you were showing up all the fancy music stuff that we get into later. But I think there is a couple of things happening, right? Heart of Clojure and also Clojure Trade during this period. Heart of Clojure was really great. I mean, it was like a beautiful venue, pretty nice late. I think it kind of a slow food sort of slow conference sort of a vibe.
Yeah, that's a nice way of putting it, actually. Yeah, it was a very slow conference, but very low beat and.
Yeah, and you could have a lot of conversations around, and it was really nice.
Yeah,
I really liked it, and it's a beautiful city, I think.
Yeah, what did you think of it, Dave? Because I guess it's your first time in Belgium.
Yeah, it was my first time in Belgium. Only my second time in Europe in my life. Really like it over there. I thought the conference was really well organized. And, a lot of great activities going on. People were organizing their own activities. There seemed like there was a lot of room for like hallway chatter and meeting people, which is, I really enjoyed that.
Yeah.
Yeah, there was also a really nice focus on not just on Clojure, but also a bit broader community issues. I really like the one with the, I don't remember the name, but he was talking about all the global warming because of the servers and stuff, and how can you reduce your carbon footprint for the servers and stuff. So that was pretty cool. Anyway, great conference. I think
just to say, by the way, that I'm working on a blockchain at the moment, but it's not the bad ones that burn up the planets. Okay, so so don't at me.
Blockchain's burning the planet. But it was a very, very nice conference. Of course, thanks to Arne and Martin who made the conference a reality, I think. So I had a wonderful time there. And then, of course, we met up there, and then we had nice pasta in the evening.
Yeah. So yeah, it was really, I felt like really starstruck, actually. There's all these people that have known for a while on the internet, like on Twitter or whatever, on the Clojure and Slack, and I got to meet them all in person.
Yeah,
that's true.
Do you go to a lot of conferences, Dave, or is this a sort of one of your first Clojure conferences, or do you go to a lot in the US, or have you been to? I know they don't have that many in the US.
Yeah,
but
the tides are changing.
Yeah.
No, I go to 1 or 2 conferences a year. AdZerk's whole thing is focusing on our professional development and making sure we go out to conferences and learn things. I've been to a few Clojure conferences before. Clojure Con they have here in Durham every year.
Oh yeah, of course, yeah.
That's going to happen again this November.
That's
the Mecca of Clojure.
Yeah.
Yeah, I've really got to get to it one of these days. I'm hoping. But it's a bit late now. It's October. I don't know if I'm going to make it.
When is it?
It's end of November, I think. Like either right before or right after Thanksgiving, which doesn't mean much to you guys, I suppose.
I mean, for me, absolutely no. I think it's the turkey thing, right? Is it the
it's basically to eat as much food as possible and hang out with your family and drink all day. We have fake turkey every year. We have tofurkey. I'm also vegetarian.
This is also another. It's not quite a first actually, because we've had a few vegetarians on, but it's nice to have a complete vegetarian podcast, keeping our brand up to date. Yeah.
Got to keep that ratio of vegetarian guests to non-vegetarian guests up.
Yeah. Well, we do ban eating meat during the podcast. You know, we're not very good at enforcing it, but it's an honor system.
We can guarantee our audience that nobody is eating meat during the show. Like the stuff that you see in the movies, like no animals were harmed during the making of the movie.
We really
it's
should.
something
We
like
really
this.
should insist that people don't eat it while they're listening to the show. That would.
That they should be.
Yeah.
So,
Tweet us if you're eating meat during listening to Defen. That would be quite interesting. Or if you're having like a nice vegan meal, that would be good as well to tweet that one too. So that would be nice.
So, Dave, so how did you end up at Heart of Clojure? So what is your journey into Clojure? So where did you start? Can you give us a bit brief bio?
Sure. So I'm a self-taught programmer. I've been working at AdZerk for about 5 years. It's actually my first software development job. Studied music composition and bassoon performance at UNC.
Bassoon.
Bassoon. If you didn't know, it's a double reed wind instrument. It's very long and narrow.
Beautiful instrument, yeah.
Yep.
I have never seen it. Is it like a wind thing, or is it strings, or is it?
It's a woodwind.
Okay. Wow.
Yep.
It's like a big hard flute. I mean, I don't mean that. That sounds naughty. It's like it's not a flute. It's more like a big clarinet, isn't it? I guess.
Well, it has two reeds. It's a double reed instrument. So, like on the clarinet, you have like the mouthpiece, and there's a single reed that you're flapping your tongue against. On a bassoon, there's two reeds, like this. You can sort of like
but people
up
don't
against each
see
other.
that. People don't see that part, do they? They just see the big end, the output part.
So I'm putting my fingers together like it's a double reed.
So Dave is doing something like a shadow puppet of a crocodile,
like a duck, I think I'm going to say.
like a duck. Okay.
So that didn't work out too well. Anyway, studied music in school. Got into software development later. I've always sort of been interested in computers, but didn't really make a concerted effort to learn how to program until after college. And I just started like devouring programming books. I started with, I think, Python and then Ruby. And eventually I got into functional programming, learned some books, read some books on
But
Haskell.
why the shift? Because you have like a professional musical career or something, or that's what you are building up to, right, with your studies?
Oh, no, I kind of went into college knowing that I wouldn't make anything with music. I mean, make any money doing it.
Yeah.
Yeah, my mindset at the time was like, oh, I just want to get a 4-year degree in something, and then that'll help me get a job, right? And it ended up falling into a career that was unrelated to music or software development at all.
Yeah.
Sort of like a desk job. I was there for like 6 years. And then in the evening hours, I was sort of like thinking about maybe I should switch careers at some point. This isn't very rewarding. So I just kind of started teaching myself more and more about programming.
Cool.
But there is a big intersection of people going into programming and then music as well, right?
Oh yeah, I meet tons
They
of
seem
people.
to be kind of logically similar or something.
Yeah, really. I think there's like a part of the brain that is active when you're either playing music, maybe writing music, I don't know, and writing software.
Yeah.
I think we have to be careful here, listeners. Correlation is not causation.
Yeah, that's true.
So people should go back and then learn music theory properly before they can become programmers.
It'll make you a better programmer.
Exactly.
I'm not going to back that up at all, but it sounds like a good thing to say.
Welcome to my TED Talk.
That's
Sorry,
anecdote.
go on. So yeah. So you had 4 years of music courses and music degree, and then you started learning Python. And then what happened?
Yeah, well, actually, I took one computer science class in college. It may have even been like CS 101. It was like Introduction to Programming. And that was Java. And I really liked it, but it seemed like a lot of ceremony. Like, this is not for me, A lot of stuff here I don't understand, all these import statements and stuff. So I kind of put that aside. And then later, when I found out about Python, it's like, oh, I can actually write scripts and things. Like, it's not hard to do this. And then that kind of got me going.
Then where did you discover Clojure then?
I actually don't remember. I think it may have been, this is like early 20, the teens. What do you call it? Decade? The tens? The teens? There's a book that came out called 7 Languages in 7 Weeks.
Oh yeah, Bruce Tate or Bruce Tate. I don't know how to pronounce his name.
Yeah.
Pragmatic
Tate, yeah.
book. Yeah, yeah.
Yep. So I don't remember. That may have been my first exposure to Clojure. But yeah, that book, I really liked that book because it was like a survey of wildly different programming languages.
Yeah.
And yeah, Clojure caught my fancy because at the time I was really into Ruby and I liked the metaprogramming aspects of Ruby. How you can make a DSL to kind of, make your own language inside your program to describe what you're trying to do. And in Lisp, like you can really do a lot with that. Like that's metaprogramming to the extreme.
Yeah. And then you joined AdZerk then after learning Clojure.
Yeah, this is like maybe a couple of years after I'd been programming in Clojure for a while.
Yeah.
And during that time when I was working the desk job and tinkering with programming in my off hours, that's when I started creating Alda.
Okay.
Right.
So you already started before you started working and getting paid for writing software.
Right. It's just something that I really wanted to do. Actually, a little anecdote there. There's a little anecdote because there where, sorry.
No, go for it.
Go ahead, please.
Yeah. So I was working this desk job, and sometimes I would get all the work done for the day that I could possibly do, but I still had to be there for 8 hours a day because that was the rule. And so I was kind of looking around. And I was like, what can I do with my time now? I mean, I could like get out this big sheet of manuscript paper, like sheet music paper, and start composing music, but that would look kind of like I'm obviously not on task. So what if I could open up Notepad, on the Windows machine that I was working on, and just like start typing in a text file and compose music that way? I think that may have kind of planted the seed for Alda a little bit.
That's nice. So we are. I mean, I think we should be thankful for that boring desk job then for Alda.
Yeah.
If you became professional in programming immediately, you would be writing some other junk. Like, okay, some more HTTP shit and all that stuff. That's nice. But I was digging through a bit of history, and then I think it's almost 6 years or 7 years since you started building Alda.
Yeah, 2012. I think is when I started designing the language.
Wow.
What we can also talk a little bit about before we get into Alda, because I think it's going to dominate the show. But before we do that, a bit more about AdZerk, because, like you say, they're working there, and I think that's where Misha and Alan Dipert of Hoplon and various other Clojure things. So did they kind of how did that work when you went for an interview or whatever? Did you show them Alda and say, look, I can code Clojure, or how did they kind of get you on board?
So I started going to the Triangle area. That's what we call Durham, Raleigh, and Chapel Hill in North Carolina. The Triangle area Clojure meetup group, which at the time was hosted at Cognitect. And so yeah, I went there once a month, met a bunch of people in the community, and there were a few people from AdZerk who would attend the meetups. And so at one point, somebody, I think Alan actually mentioned that they were hiring. So I was like, oh, okay, I'll look into this. Yeah. So I think it's like I just happened to be in the right city to get interested in Clojure.
Yeah. Right. And did you know that Clojure was next door to where you like the heart of Clojure in the sort of headquarter sense? Did you know it was there when you were learning Clojure, or was that did you find that out afterwards?
No, I found out afterwards. It was like this weird coincidence. Another weird coincidence is that I read the book early on when I was learning Clojure. I read Clojure for the Brave and True. By Daniel Higginbotham, who also lives in Durham.
Oh, right. Okay.
Oh.
Yeah, I read that book and I was like, man, I really like this book. I want to tell the author how much I like it. So I went on the website and there's his contact information. And I was like, wait, that's my zip code. I could walk to this guy's house.
So did you?
That's nice.
No, that would have
been a scary stalker,
And that's where he got his, what do you call that? An order to stay away 500 feet or something?
Yeah, that's why I have a restraining order from Daniel.
Have you met him in the Clojure meetups though? Does he go there?
Yeah, he did some contracting work for AdZerk for a while, so we were coworkers.
Oh, right, okay. So you did finally manage to get to say hello.
Yeah.
It's like the Hollywood of Clojure, all the celebrities living in the 50-kilometer area.
Yeah. Yeah, one of the first talks that I attended there at the meetup was Stu Halloway was talking about Datomic. and that just like blew my brain apart. Like I barely knew about databases at all, and then he's talking about like, the element of time and like being able to like immutable database.
Yeah. If it is not too revealing, so what do you do at AdZerk using Clojure? How is the stack? How does the stack look like, and what kind of challenges that you're, or what kind of things that you're solving there?
Yeah, so we're like, I guess you could describe us as sort of a world-class platform for decision making at scale. The use case is typically ad serving, and we enable people to do sort of better things with advertising in like the native advertising space. So the part of the system that I work on most is what we call the configuration or the management side of things. So people are kind of funneling ads into the system and configuring how they're supposed to serve. Oh yeah, there's like it's sort of like service-driven architecture. There's a bunch of different services, mostly written in Clojure. We're all sort of Clojure fanatics here. So there's a few older systems that are written in other stacks, C# and some Node.js and stuff like that. But all the new stuff we're building is in Clojure, and we're working on replacing the older stuff with Clojure. So there's sort of some sort of like porting effort going on too.
Just a non-technical question in some ways, like a business question, but it's like, are you looking at personalized ads, or is it more kind of like looking at demographics or sectors or other kind of non-personal splits?
Well, we're really sort of like the toolkit in that whole thing. Like we enable people to build exactly the type of ad serving experience that they want. So the idea is we're trying to get customers who are more interested in doing like more humane sorts of advertising. Which is, you could use some element of personalization, but the hope is that you leave really sensitive information out of the equation and just focus on stuff that, like if you're browsing some website, you probably want to be shown ads that are relevant to your interests, but not in an invasive way.
Right. So you per se are not actually a surveillance company. Just
not per se.
That. Yeah. That's good to know. Good to know.
So I was there in, I think last week I was there in a big conference called Data Council in Barcelona. It's about data and all this stuff, machine learning and AI, and also the data engineering stuff. So there was a company, somebody doing like a similar kind of ad delivery thing, but it's a real-time bidding. So I didn't know that while you are scrolling on a mobile page, they immediately send this space is available, and then there is real-time bidding going to happen, and then people can push the ad then.
Oh,
because
yeah.
The ads that I'm used to is like Google AdWords or something. You give some publisher and then you're done. Then you sell the space and you don't care what it is going to be shown.
Yeah, so that's sort of like the old
crazy.
world of ad serving, where you just have like a banner on your site. You don't particularly care what the ad is going to be. It could be something really inappropriate or not relevant.
Yeah.
So the new idea with native advertising is, you can collect just the information, or sort of collect the information that's most relevant for the types of ads you want to show. And a lot of it is more like content on your website. It might be sponsored content. And it's clear that it's an ad, like you'll see the word sponsored next to it or something. But it has to do with like whatever area of the website that you're in, or if you've sometimes if you've bought something, you might get ads for related things. That might be something you're interested in doing.
Yeah. At least it's not that level creepy that I'm in a Wi-Fi network and then someone else who is sitting beside me and then he's searching for hotels in Barcelona, and then I just get the ads of hotels in Barcelona because it's the same Wi-Fi network, and then they keep thinking, oh, these people must be in the same home or something. So it's super creepy sometimes. But so how's the like what kind of database you use and what kind of libraries do you use? Do you use Hoplon there as well? Because I know Misha and Alan. Yeah.
Yeah, we have a huge Hoplon application that there's all sorts of cells all over the place. We coordinate them together. It's
nice.
Yeah, it is interesting to see Hoplon work at that level of scale. Like, you see a lot of the examples. There's like, you can do a to-do application and things like that, which is, you're not really stressing the system there. But we have like, we're making all these database queries in the background and updating like the results in different cells and things like that. It actually works really well.
Okay. And what is the database that you're using? Do you use Datomic or do you use Postgres, or what kind of database that you use?
We're using Microsoft SQL Server.
Wow.
Yeah.
Fine.
Yeah, that's the legacy system that it's sort of tied to how things are working in that database.
Yeah. Well, I think once you abstract it away using, I don't know, some libraries, then probably you wouldn't be worrying too much about what SQL server, what type of server is there.
Yeah,
I
true.
think.
Although it can do some pretty interesting things. There's like change tracking in SQL Server. Have you heard of this?
No.
It's kind of neat. You basically get like a log of things that changed in the database,
Oh.
which is almost
so like you have like an audit table.
Yeah,
Yeah,
it's like
yeah. Right.
CDC, isn't it? Change
Change data tracking.
something. Change
Capture.
data something.
Capture.
Yeah, capture.
Oh, capture. Yeah, that
Change
one.
data
Yeah.
capture.
Yeah. Nice. And so because you were not, let's say, tainted by years and years of Java and stuff.
Right.
So how did you see or what is your, because there is plenty of front end code that you're working on, like Hoplon and with Clojure script, and I'm assuming there is a lot of back end code as well.
Mm-hmm.
So was there any leaky abstractions that you had to learn more JavaScript, you had to learn more Java to get more productive with Clojure script?
I want to say Clojure script kind of hides a lot of the mess of JavaScript.
Yeah.
Like, I mean, there's some things you have to know, like, why is this, like you have to know to disable, like if you're doing a click handler on something on the front end, you have to remember to do like prevent default.
Yeah.
To
prevent the DOM events. Yeah.
Right. So little things like that you still have to know about that stuff.
Yeah. And on the server side, do you get into more Java side because that kind of libraries that you're using?
Yeah, like we've actually been tinkering with different ways to do SQL queries, and a while back we decided that Clojure Java JDBC didn't meet our needs. Although JDBC Next is looking a lot more promising. It's kind of similar to the thing that we ended up hand rolling something that's very similar. So there's a lot of like interop with like JDBC and stuff like that.
So maybe we can now switch to music.
Yeah, sure.
and talk about the new language. So what is Alda? Where did it come from? We know where it came from the boring desk job, luckily. But how did you build it, and what is the value proposition?
Right. So Alda is a text format for music composition. It's like, imagine if you could write music by writing text in your text editor, and then highlight just the part that you want to play. Maybe press a couple of keystrokes and hear it played back. I was very inspired by the Unix philosophy of things. So I wanted to make a command line program that its job is to take some text-based input that represents music and play it. So it's just like...
So you can like echo and cat all the instructions to Alda.
Yeah. So if you want, you can actually write a program in some other language and like emit Alda syntax and pipe that into Alda. So I do something quite like that with, I've written a lot of music where I write Clojure code that generates Alda. And you can write algorithmic or like procedural music that way. So
you're an algo raver, are you, Dave?
One day I hope to be. Well, I'm really more of an algo composer.
Okay.
So what is the, so it's how does the architecture look like? Because it's so you write your sheet music, or you write your music with notes and essentially with text, plain text, and then you feed that to Alda program, and then what happens then?
Yeah, so actually it's changing now. I'm actually working on Alda V2, which is architected differently. But I'll just talk about V1 because that's what we have in the releases today. So it's actually...
we can tease them about V2,
at
the end.
I absolutely want to, yeah. Yeah, I actually just gave a talk at Strange Loop where I talked about all this stuff. I gave the history of the architecture of Alda. So that talk is on YouTube.
I just saw that.
No one watches Strange Loop. They all listen to this.
Yeah, so anyway, so we have this, the client is actually a Java program. It's a very thin program that just talks to a Clojure server that's running in the background.
Right.
That's basically like my hacky workaround for Clojure's startup time.
Okay.
But did you try GraalVM or something to make it go faster?
I haven't experimented with GraalVM. The decision to split it out in a client server was years before GraalVM
Before,
came about.
yeah.
Or you could use Node.js or something like that as well, like Plank or what's the other one called?
Lumo.
Lumo, yeah.
Yeah.
Yeah, so there are different ways to skin the cat nowadays in 2019.
Yeah.
That's true.
Okay.
Yeah. So there is a client program and then there is a server program in Java.
Yeah, I actually
Is that
distribute them
right?
as a single executable though. There's this trick you can play where you have an Uber jar that has both Java and Clojure code in it, and then you can make that whole thing an executable,
Different
like a
entry
self-running
points.
jar.
Yeah.
So the client will start the server in the background.
Okay, so the feed or the input is basically some text representation of the music.
Right.
And then
It's like a markup language for music.
okay.
Oh, right. Okay.
And then there is an interpreter, or how is it producing the sound from that one?
Yeah. So the Clojure program, the server, is taking the input, parsing it, turning it into an AST, and then it will sort of build up a score data structure in memory. It's like basically this big hash map that has all the data about the score. And then it performs it, it interprets it by using the JVM. There's actually a MIDI synthesizer built into the JVM. So it uses that for playback.
Okay.
Wow. Is that by the way? I mean, I don't remember the details anymore, but I remember there was a story about it a while ago that certain parts of the JDK weren't ported to OpenJDK, like these audio drivers. Is that the case, or do you have to use the Oracle distribution, or can you use like the OpenJDK or some other one?
Nope. All the OpenJDK does work for the MIDI. The package is javax.sound.midi.
All right.
Thankfully, that's not one of the ones that Oracle decided to pull out.
Phew. Okay, good.
It's a nice thing because, I mean, it doesn't require you to install anything extra in order to hear the sounds. Like if you have Java installed, Alda will work on your system.
That's ideal. That's perfect. Yeah.
So this is the V1 architecture that you're talking about.
Yes.
The one that we download right now, that's what you get. Essentially a Java program and then some Clojure code base that is going to do the parsing and translation.
Yeah, all of the work. It parses your input and figures out what you meant music-wise and then performs it.
So how do you account for things like, like two instruments in the score playing at the same time? Is that part of the markup text? Like you have instrument 1, instrument 2 or whatever? I mean, maybe you can explain it a bit.
Yeah, that's actually, so an instrument part is sort of the top level element syntactically, or, like in the AST. So you have, you basically say, you can say violin, colon, and then have all the markup that represents what that violin is going to play.
Maybe you could give us a quick demo of it, Dave, just like, saying like piano or ABC or something. Yeah.
Yeah, actually, so I have a score pulled up here. This is an excerpt of a string quartet by Debussy. And so I'm just highlighting just
that's
one
not the Hello World,
part.
is it?
Oh, you want me to start with Hello World?
Yeah, I think that's easier for us.
Yeah, all right. So
we're slow learners, mate. Come on.
Yeah, we'll get to Debussy later.
Yeah.
Okay, so so this is a string quartet. So that's 2 violins, a viola, and a cello.
Okay.
And so we've got, this the code that I'm highlighting. I hate to talk about code that I'm, this is what I'm. So it's violin, and then in quotes, violin 1. So that's like the name of that violin. That's useful because you can have multiple violins.
Right.
And then some markup that basically says in the 4th octave, play the notes A, C, and B. And you can say how long the notes are as well. So this is what that sounds like. Oh, hang on.
Oh, so you also specify the duration in the text to say the last note to play longer.
Right.
Okay.
So the first couple notes were half notes. So I said A2.
Yeah.
That means a half note.
And
then,
right, okay.
And then C, because the duration is sticky, you don't necessarily want to have to put the duration on every single note. So it's just C. And then you have B, which is a whole note. So that's B1.
Okay, so it's more like a
Okay.
state. So it remembers the state then, right? Because if I change the state at some point and then going forward until I say something else, it keeps that state in
Right.
terms of beats.
Yeah, there's a trade-off there because as functional programmers, we don't like to rely too much on previous state. That's
Yeah.
I've gotten that criticism before, but I think it sort of keeps things concise because a lot of the
Yeah.
time you don't like you'll sort of now you're in 16th, you have like a run of 16th notes, which are faster notes, and so
Yeah.
you'll just put the 16 on the first one, and then you have a bunch of notes that don't have durations on them, and it's implicit that they are 16th notes.
I think there's personally, I think there's a big difference between how you program things and how you annotate them. I mean, to me, having an annotation which has memory of the previous state to save the author, I think that's really good. That's got nothing to do with functional programming. That's just an annotation thing.
Yeah.
That's a convenience for the scribbler. That's
right.
How you programming it. You can program it as stateless or as stateful as you want. You can just expand that, and so you don't rely on previous state. So I don't think there's a problem there.
Yeah, that's a good point.
So screw those guys.
Yeah,
we're here to defend you, Dave. Come on.
I will say that my sort of my target audience for Alda is people who don't necessarily know how to program.
Yeah, exactly. Yeah, exactly.
Makes sense. Yeah.
Yeah.
But how did because you started this before you learned Clojure, is that right?
Yes.
Building Alda. So how did learning Clojure influence Alda later?
That's an interesting
any
question.
Influence.
Yeah. So when I was first designing the language, there are a couple of existing music programming languages that I stole some ideas from. There's LilyPond, which is a great language for music engraving or generating sheet music.
Is that what you call it? Is it
engraving?
Yeah.
Yeah, it's an interesting
I've never
term,
heard that phrase before. Yeah, it sounds like something you do in a graveyard. All right.
Let's engrave the music.
Yeah.
That's basically putting them into a grave.
I don't know. I always think of engraving as something you do on metal or stone or something, but I guess
Yeah.
music's
like
old, isn't it? So
no. Originally, they used pen and paper, but with the Industrial Revolution, we had I'm blanking on the name of that machine. The important one that printed the printing press.
The printing press. Yeah, that's
yeah. So there are special sets of whatever those things are called, the stamps or whatever that.
Yeah.
Oh yeah.
That are different shapes that are used for music, like quarter notes, and eighth notes, and things like that.
Okay. And those were engravings. Yeah.
Right. So that's where music engraving originally came from.
Right. Okay. Sorry, a bit of a
makes sense.
Yeah. It's a little tangent there. But LilyPond, it's a
okay.
music engraving language because it's like they brought that whole process into the digital age. I mean, there were already programs for this, but they wanted a programming language that did specifically that.
Okay.
But anyway, there's some really interesting syntax there that if you look at LilyPond and then look at Alda and compare them, you'll see how I stole a bunch of ideas from it.
Mm-hmm.
And there's another language called MML, or Music Macro Language, that was a big influence. That's the language that I don't know if you remember from the flip phone era, like early 2000s. There was a time where a lot of people were programming their own ringtones for it.
Yeah.
Right.
Yeah.
Okay.
That language was a dialect of MML.
Right. Okay.
And they also there's other dialects of MML that run on like old BASIC machines, like from the 80s.
Right.
And so that was like an early computer music language.
Yeah. Well, low tech is the way to go. Yeah.
Yeah. But I like the syntax, so I took a bunch of ideas from those things.
Yeah.
VJ, you're asking me about how Clojure influenced things.
Yeah.
So something interesting that happened after I started implementing it in Clojure was that at some point I decided to expose evaluation semantics. So part of the syntax of the language is just Clojure S expressions. A simple example of that is just like open paren volume 50, close paren.
So it's an embedded DSL as well now.
Yes.
Okay.
And you have, because we're really just we're invoking eval on whatever Clojure code you have in there. You can use the entire Clojure core standard library, which is full of really useful functions for dealing with sequences of things.
Yeah.
And in scope is this whole library of music functions like chord and note and things like that. So when you combine them, it's this really powerful language for algorithmic music.
But maybe kind of a small digression or something. I was thinking, so the kind of music that you can quote unquote program and the kind of music that you write without programming, do you think there is a difference? Because it seems to me like if I'm coding, then all this coding mentality comes into the music. Is that, I don't know how to put that one. Like because if I'm thinking about a song, I don't think about loops. I don't think about whatever for loops or whatever and these kind of things.
Right.
So is there any creative difference between these two in your opinion?
Yeah, absolutely. I think it's just it's basically the system that you have at hand for notating your music can influence the type of music that you create. And like you can write music that's more similar to the type of music you would write if you're just sitting at a piano with sheet music paper and writing it by hand. And you can also, if you have a Turing complete programming language at your disposal, like Clojure, you can do kind of wackier things or generate lists of random integers and have that inform your pitch content and things like that.
So do you kind of think about like the REPL experience as well as part of that?
Yeah, so Alda has a REPL. We call it the read eval play loop.
Oh, nice.
Nice.
Yeah, but that's useful for experimentation. You can just pop the Alda REPL open and try out bits of syntax, and here's small snippets played back. But an interesting thing, so I created a Vim plugin for Alda. I think I just answered your question, Emacs or some other shit, right?
Exactly. Yeah.
Some other shit.
Yes, I'm pretty sure Emacs can be plugged in as well.
Yeah, there's an Alda mode for Emacs.
Yeah, perfect. Then your sins are absolved. So please go on.
Great. Right. So an interesting thing happened as I got more into Clojure, and I learned how you can just, instead of just having a REPL open in a different terminal, you can integrate it with your text editor, and that it makes you more proficient, more it's efficient, and you can evaluate things more quickly. Yeah. So that's the way I've started doing things in Alda. I actually rarely open up the Alda REPL anymore, unless it's like I just want to try something out really quick. Just like with Clojure, like a lot of the time I just have the REPL plugged into my editor.
Yeah. So if the music composition process, is it something like if you don't have something like Alda or a computer, then you write a small what do you call, like a staff, whatever, and then you play it on piano and then change one note and play it again. So is that like a repetitive process like that in general?
Yeah, totally. It's like an iterative process. You come up with an idea, play it back, and then say, oh, what if this one note had add a sharp to it, make it a little bit higher, see what that sounds like, and you play it back, and when you come up with an idea you like, now you've got it in your buffer, and you can repeat it or experiment with it.
So with things like Alda, the loop becomes really tight. I mean, it becomes really quick because you can just change it and then play it immediately. Yeah, it's really nice.
The tight feedback.
I must say, I mean, I downloaded the app, I downloaded the software, and then it was super easy. I was surprised. I was able to type some things, and I was looking at some sheet music and the beginner stuff that I know a bit. It was really, really smooth experience, I must say.
That's awesome.
It's an awesome job.
Thank you.
Because making computers make music, it's been, I think there are plenty of software like this, right? I mean, there plenty of experimentation, like how to make it more effective.
Yeah.
So
I think they all cover different niches. Like a lot of people ask me, well, how is it? Is it like Overtone, or is it like Sonic Pi? And those are two great projects by Sam Aaron. One of them is a Clojure library, Overtone. And those are great, but they sort of serve different purposes. Like you couldn't get a music composition student to pick up Overtone, and if they they don't know anything about programming, and have them start to be productive with it.
Yeah.
So I think that's why they went with Sonic Pi, wasn't it, to try and make it more amenable to kids?
Yeah.
So what's your target audience, Dave, actually? What's your kind of demographic, let's say?
I would say it's anybody who is close to the intersection of music making and programming. So either there's sort of like two groups of people. There's like musicians who don't know much about programming and they want to kind of experiment with making something by writing code. And then there's programmers who don't necessarily know anything about music and they want to learn about music theory or making music. I don't play an instrument. How can I make music? So they can, they know how to write code. So this enables them to do that. And you can explore different music concepts by learning how to notate it with Alda.
So what is it? What is an instrument, by the way, on Alda? Like how does if I say piano and then if I change it to the fancy instrument that you're talking about before,
bassoon.
So
I can do that.
Yeah. Yeah.
Okay, so here.
How does it sound?
Yeah, so here's a piano doing a C major scale. This, by the way, is the Hello World of Alda.
Yeah.
And then I can just change the word piano. So it says piano : and then some other stuff.
Mm-hmm.
So I'm going to change piano to bassoon. And I'll, instead of octave 4, I'm going to put it in octave 2, which is sort of more idiomatic for the bassoon.
Mm-hmm. Oh, okay.
Sweet.
Yeah.
So what changed there? Like in terms of a program, the instrument is already predefined, or can we create our own instruments? And can you explain how those things work?
So right now we have the 128 general MIDI spec instruments. There's a spec for MIDI, and they've defined 128 instruments, and so all of those are available in the JVM built-in MIDI synthesizer. So we call that the MIDI term for that is program change. So piano is one program; it's program 0, and then bassoon is I forget what the number is, but it's probably program 37 or something like that.
So the actual so what you're naming this instrument, that's basically an index into some synth in Java, essentially.
Yeah, there's like a lookup table of strings to what patches this.
So can you create your own instruments out of those things, or just a combination of these ones is how you compose the music?
Yeah, right now it's just those 128 instruments.
Well, that should be enough, I think.
Yeah, it's fun to play with them. Yeah, it is.
Yeah.
I mean, there's a certain breed of musician who really wants to mess around with creating new sounds and messing with synthesizers and things like that. I'm interested in doing that myself. So at some point, I would like to see if I could add different types of instruments that are synthesizers.
Okay.
So is the MIDI of Java, is that extensible?
No, not really. Not in the way that I think you're saying, like, can you add instruments to it? And not really. Well, so an interesting thing about MIDI is that MIDI itself does not have a sound. It's really a message format. So you can emit MIDI messages, and then those go into some sort of synthesizer. So the JVM is just one instance, or the JVM MIDI synthesizer is just one instance of a synthesizer. But it would be pretty easy to just emit these messages out into out on some port, and then plug them into a software synth or maybe even a hardware synth.
Right.
And then you can really you could say that, like, okay, now patch 37 is this weird synth sound that I programmed.
Okay. So can you did you test the limits of this one? Like, can you create like an orchestra of whatever number of instruments and then play them, and then what happens then if I have like 120 violins or whatever?
I actually don't know if that would work or not. I've mostly been composing for, I've composed for up to like 8 instruments before.
So you don't know if we play like Mahler's Fifth, you don't know about how that would work?
I have a feeling you might run into some issues with parsing huge input things. Like, I hand-rolled the parser myself to squeeze the most performance out of it, and you might run into some weird edge cases or something. I'd be curious how that works out.
And in terms of architecture, I think one of our listeners should try it.
Yeah, it would take quite a while to transcribe a whole orchestra piece like that.
Hey, that's why you have Clojure for us, so
Yeah, come on.
Yeah, well, hey, you can generate an orchestral piece.
Exactly. Yeah. And then see what happens. And so every instrument is playing separate thread, or how is it working? Because if it is all of them are playing together, how do they synchronize?
So there's this other concept in MIDI that's this is another class that's available to you in the Java X Sound MIDI package, which is called a sequencer, and so that gives you the ability to send MIDI messages in time. And it's really great because it actually, it might depend on the Java implementation, but it's using threads on your audio card, so it's not affected by GC and things like that. So you actually get pretty solid timing.
Yeah.
So really, it's like what we're doing is we're loading up the sequencer with note data. It's sort of like you're popping a cassette tape into the player, and then once it's all loaded, we press play, and it all plays in time.
Okay. So it's converting all these things into like a series of things that can be sent, and then there is no delay between multiple things. Okay.
Right.
That's really nice.
So basically, it's a kind of translation layer between your notation and MIDI.
Yes, exactly.
Okay.
So how is the performance, by the way, with Clojure? Because so the parsing part is happening in Clojure, and then you generate MIDI messages. So how is the performance, and what is driving you to write V2 of this one?
So yeah, performance is pretty good overall. Like I have a pretty good time with it. There's some architectural issues that have come about. That's really what I wanted to work around for V2. So I would also refer listeners to the talk I just gave at Strange Loop for the gory details of this. But basically, we've ended up at this place with Alda V1 where we have 3 different types of process. There's the client, there's a server, which is really just a go-between between the client and this other thing, which is a worker process. And so the server is like supervising these other background processes that are sitting around waiting for input and playing the score. It's not great because we have to. For a variety of reasons. One of them is that some users have reported issues where the worker processes just do not start. So they see the server come up and then it's like, all right, starting workers, and then it just hangs there. I think on like Windows and maybe other operating systems, there's issues where a background process can't start its own background processes. So it's just gotten kind of complicated, and I wanted to simplify things. So I'm currently working on a new version of Alda where everything is done on, as much as possible, is done on the client side.
So all the translation into MIDI is on the client side, basically.
Yes.
Yeah. Okay.
And so we do still have a background process because I wanted things to. I think it should be an asynchronous type thing where you just fire off, this is my score, play this, and then that happens by some other process in the background. And you can come back along and stop it before it's done if you'd like to.
Because I think the browsers have MIDI these days, don't they?
They do. There's a library called MIDI.js, which is really good. I've had some pipe dreams about porting the player part to Web Audio API and doing stuff with MIDI.js.
Yeah. Well, I mean, version 3 or, it's like...
Yeah, maybe that'll be version 3.
Yeah. Sorry, you're going to say, Dave, you're going to say about the browser has got some other things.
Yeah, it also has a synthesizer built in.
I didn't know that.
No.
Okay.
Well, it has the low-level parts, so you can build your own synthesizer. So they have oscillators and different types of filters and things. So people have built modular or analog synth or quote-unquote analog synth type things in the browser.
Yeah. When I've seen some like when Web Audio first came out, I saw some like stuff that was linked to like music that was linked to video images, so that you could in real time create like music in the browser and that was reacting to the kind of images that were being put out there, which was
that sounds cool.
Very smooth. Anyway, obviously you're putting a lot of pressure on the graphics card, and I guess you have to have a good graphics card and a good sound card. And sometimes the WebGL isn't as perfect as you'd like it to be, but that's a different story. Right. So WebGL talks directly to the GPU. So in theory, does Web Audio speak directly to sound cards, or is that?
Yep.
Is that it does? Okay.
It does. Yeah, I've looked into the timing things. I actually have a Clojure script library that deals with timing.
Right. Okay.
Involving the Web Audio API. It's called Chronoid because it's time related and it's for rock solid scheduling. So that's the OID. Yeah, kind of a dumb name, but anyway. Yeah, so there's this article by I'm blanking on his name, but a guy who actually worked on the Web Audio API. The article is called "A Tale of Two Clocks," and it's all about how to schedule events in the browser.
Right.
And basically, the answer is you have to kind of you have to coordinate between this. There's like you can get access to the audio card, and there's like a clock running there, and you have to coordinate that with like your browser's event loop.
Yeah.
So Chrono does that for you kind of behind this. It implements the algorithm that's described in that article. So you can say like, in 3,000 milliseconds, play this, or at this timestamp, play this, and it'll do it with good accuracy of time.
So what is the technology change from V1 to V2?
Yeah, so this is the part where I get kicked off the show because I'm I'm re-implementing it. So the new architecture is there's a client and there's what I call a player, which is kind of like the worker now, but all it does is literally just play. Like all the work is done client side. The player's job is just to perform it. And so the player is written in Kotlin and the client is written in Go.
Wow.
Yeah.
Okay, see you later.
Okay,
Dave.
that's the end of the episode number
It's been
50.
great. Bye, guys.
But why Kotlin and why Go?
So
what changed there?
I'll start with Kotlin because that one's easy. It's really like that was sort of an arbitrary decision. Actually, I could have done that one in Clojure because this is a background process. It doesn't necessarily matter how long it takes to start. So I could have gone with Clojure, but as a bonus, I wanted to have a quick startup time. I might actually experiment with rewriting it with GraalVM compiled Clojure.
Yes, Clojure. Yeah.
But I needed a JVM there so I could use the MIDI sequencer synthesizer.
Yeah.
And then on the client side, I really just wanted as much performance as I could get without dipping into something I can't tolerate, like writing C or C++. And another important, so I tried a variety of things. I tried Rust and Crystal as well. I like those languages.
Yeah.
But what the tipping point for me that made me decide on Go was that it was the platform that allowed me to most easily create cross-platform native executables with absolutely no dynamic linking. That was the key part.
Right. And it's just like you just drop in one image and bam, you're off. Yeah.
Yeah, I did some experiments and it was like very easy to use Go to just spit out Windows, Mac OS, and Linux executables that they have no native dependencies.
Isn't that the same with Rust as well? Because I didn't do any cross compilation on Rust yet, but
yeah, you can do
similar.
You can do cross-platform compilation fairly easily with Rust, but I think some of the Rust standard library might still depend on libc.
Okay.
So there's an element of like, the system I'm trying to run this on might not necessarily have the bits that it needs without installing some other library.
Yeah.
So it just goes back to wanting to provide a good experience for people who aren't familiar with programming and like tinkering with compiling their own executables and stuff like that, making sure you have the right libraries installed.
Yeah. Yeah, I think it makes sense because especially you need the performance and you need the startup time not to be that much. So in those cases, it's the right tool for the right job, especially music related things. I mean, people don't want to wait for, 10 seconds to start the program. And then
yeah, exactly.
So that makes sense. Yeah.
It's been interesting because Go is not my favorite language by any stretch, but just through using it a bunch, I don't know if it's Stockholm syndrome, but I've kind of gotten used to it and it doesn't feel as bad to me now.
Yeah, I think familiarity.
Right.
Did you use the? Because I used Go for a while as well, and I was to be honest, I was pretty glad to be rid of it. But I didn't use it as heavily as you did. But are you using any of the kind of async features of it? I mean, the sort of, or is it just a means to an end to get cross-platform executables?
So far, I'm not finished implementing this yet, but I've gotten pretty far with the Go part. Yeah. I'm pretty much done with the Kotlin part. That part took me, a week or two. I could easily rewrite that in some other, because what it's doing is pretty minimal. The client side, I haven't found myself needing to use Go routines yet. Like the performance is so good, like it parses things in microseconds.
Right.
And the performance is so good, I just haven't need to introduce concurrency yet.
Yeah, but the core language is still Alda plus Clojure then.
Oh, that's a great question. So it's really important to me. I haven't demonstrated this yet. Maybe I will. But I like to write Clojure code that writes musical compositions. So maybe
Yeah.
I'll play you an example if you're interested.
Yes, of course.
Totally.
All right. So I like to sort of just tinker with my Clojure REPL, just writing with the Alda library kind of loaded. So there's okay. I got to introduce Alda CLJ. It is the successor to this inline Clojure scripting layer in Alda v1. Because in Alda v2 we can't have that because now the runtime is a native executable. We don't have a Clojure process.
Yeah.
But I figured out that I can actually get the same effect. I can do exactly the same sort of thing by just driving the Alda program from Clojure. So I wrote a Clojure library that has the same DSL for music, and that's Alda CLJ. So I've used that to compose a bunch of different types of music. I probably should have had this pulled up already.
We're always winging it, Dave. Don't worry, you know.
Indeed. Okay, yeah. So, all right, I've got it pulled up here. So, in this score, I've defined a function called random note, and it will return every time you call it. It returns a random note, like a note with a random pitch, and it lasts a random length of time in milliseconds. Or it might randomly choose to rest or not play anything for a certain amount of time.
Yep.
And then I've got 3 instruments: an electric piano, a timpani, and a celeste, which is a keyboard instrument. It sounds kind of like bells.
And the random thing is Clojure.
Yeah. So random note is a Clojure function that I've defined.
Okay, it's just data in, data out. That's it. It doesn't do anything with Alda.
Yeah, exactly. Well, it's using the Alda CLJ library to return like basically records.
Okay. Yep.
And then so in Alda CLJ there's a function called play, play bang, and you give it any number of these records, and it will sort of translate it into valid Alda syntax and just ship it over to your Alda command line.
Okay.
Nice.
I'm really just shelling out. Like what it's doing is very simple. It's just sort of sending the Alda syntax, like a string of Alda code, to Alda, and Alda.
It's like a REPL, basically.
Yes, exactly. So now you have a Clojure REPL, and you can bring in your own dependencies. Like you could pull in an HTTP library and grab like I did my Strange Loop talk. You can pull in weather forecast data and use that to generate music.
All right. Okay.
And anyway, here's that.
I don't know whether it's cloudy or bright.
Yeah. So anyway, this is.
Let's listen to this.
Yeah. So let's listen to this.
Yeah.
This sounds different every time you evaluate the score.
Yeah.
You never know what it's going to sound like. Sort of reminiscent of like the art music of the early 20th century, John Cage and stuff like that.
Yeah.
So the instrument parts just look like repeatedly 20 random note.
Yeah.
Like a Clojure.
Okay. So you can still use Clojure to generate these Alda linguistic description of the music, and then that is being sent to this Go program eventually, and then that goes into the Kotlin thing.
Right. Yeah, the interface is actually the same as Alda v1, so you're able to you can go ahead and use Alda CLJ today with the release version of Alda, but it'll get faster once Alda v2 is released.
Nice. So Clojure is still there, so it's good that you're still on the show.
Yeah, I think I've redeemed myself, hopefully.
Yeah. So that's so the Clojure part is basically the algo part of the algo raves or the algo composition.
Right.
And then the other bits and pieces are the playing and the sending.
Yes. So the sort of the key realization I had was that Alda the language is really just the markup layer, and that's the way it ought to be.
Yeah.
You can drive it from other things and generate that. Implement the algorithmic part in terms of just the markup part.
Okay. So in a way, it's like Clojure, right? Because Clojure compiles to JVM stuff, and then JVM is running the stuff somewhere. So it's technically similar to that kind of division, so to speak.
Right.
So you're writing Clojure code, but then there is this Alda VM, quote unquote Alda VM, that is written in Go or whatever. And then you're just sending the bytes to that one, and that's playing it.
Exactly.
Nice. So, what other things that you do with Clojure apart from music? Is there any other
Let's
projects
see.
that you work with, or?
Well, I have some Clojure open source libraries. I've done a bunch of tinkering with ZeroMQ.
Yeah.
So I wrote a wrapper library for GeroMQ, which is the pure Java implementation of ZeroMQ, and I call that EZZMQ. The letters
Nice.
EZZMQ. It's sort of like a more idiomatic, Clojure wrapper library for the Java one is sort of tied to a lot of idioms of Java. So this gets around some of that.
Yeah. Nice. But did you use ZeroMQ in your projects already?
Yeah, actually, Alda v1 uses ZeroMQ to communicate between the client and the server and the workers.
Okay, makes sense. So that's how you ended up using ZeroMQ. Okay.
Yeah. So I talked about this a bit in the Strange Loop talk as well. But one of the early iterations of Alda where I wanted to split it out between client and server, I did like the most naive thing possible, which was just like HTTP. So the server is running, an HTTP server, and the client is just sending HTTP requests to the server.
Yeah.
And somebody pointed out to me that this is like not the most efficient way to do it. If I just want to get essentially a byte array from one place to another, there are cheaper ways to do that. So that's what led me to ZeroMQ as an option for doing that.
Yeah.
Okay. So you didn't think about WebSockets or something like that, or?
Well, this is like from one server side program to another, like just running on your machine.
Okay.
But even then, I think if you want WebSockets, then you still want HTTP handover, right? Handshake is still HTTP, so you'll bring in all this nuisance around it, probably.
Yeah.
Well, the idea with WebSockets is just that you use HTTP as a sort of introduction layer. But then it's a TCP/IP socket after that.
Yeah. Then it switches to the WebSocket.
Yeah. So ZeroMQ is basically just like you have sockets open on either side. It's almost like dealing with raw sockets, except that it's painful to work with raw sockets. There's a lot of like kind of housekeeping you have to do to make sure, the message that gets returned to whoever sent it and things like that. So ZeroMQ is like just a layer on top of that.
So you have the routers and everything in ZeroMQ. That can send the appropriate messages to correct locations or something.
Right. I really like ZeroMQ because it gives you some. They have socket types, so there's the most basic program you can write using ZeroMQ has like a pair of sockets that are request and response, and so you just create an instance of each, and in different programs maybe in different threads in the same program, and you just send messages between those two things. And they also have more complicated things. They have pub sub, and they have what we do in Alda to route messages between the client and the workers. Like there's like a broker in the middle that has what we call router and dealer sockets. So there's all sorts of it's like they give you the Lego blocks and you can build whatever you'd like with those. Yeah.
So Alda is open source, right? So what type of contributions are people can make to the library or the program?
We could really use a lot of help right now with our website and documentation. Those are areas that just I haven't. Maybe you can probably hear that a lot with a lot of projects, but yeah, I could definitely use some help with making the documentation friendlier, making the website have all the information that we really want in it.
Yeah, nice. I think some people will probably try it out at least. I think it's as I said, the user experience is, at least on Mac, because I didn't try Windows and other stuff. I'm assuming it's the similar kind of experience there. It was really nice. I just downloaded and then I just typed Alda REPL and then I could just start typing notes and then listen to some horrible stuff that I typed in. So that was beautiful. I was thinking, maybe we should, because all the notes are like, if we have sort of a normalization of the source code, then we should convert source code into music. So you just put in Clojure code and then it normalizes into the 7 notes, all the stuff that we write in. Then we should be able to provide something like, the shape of the code is this because of the music.
Whoa, that's interesting. We could analyze like the Git repo, like the Git data for a repo.
Yeah. And like you could decide whether a pull request makes you happy or not. Yeah.
And then it gives the whole new meaning of this code is too noisy, like literally. I just played it in Alda.
Right.
What a noisy code.
Yeah.
So, can you play us something more? Of course, we did we heard the Hello World thing. You're saying Debussy or whatever that thing is. I'm sorry, I'm like completely like level
Debussy.
0, level -2.
Claude
Yeah, Debussy was
Debussy. Yeah.
Let's do that. I've also
Yes.
got the weather forecast piece that we could listen to if you're interested.
Let's do it. Yeah.
You want the weather forecast?
Let's do the weather forecast. Yeah.
Yeah, I think this one's pretty interesting.
Are you choosing a particular location or?
Yeah. So what I did was the purpose of this score was to demonstrate that you can, now that you have control of the Clojure part, like you are using Alda within your Clojure REPL. So you can pull in whatever libraries you'd like. So I used, an HTTP client and a JSON library. And now I can consume the National Weather Service API and get weather forecast data. For this example has 4 cities. There's New York, LA, St. Louis, and Durham.
Well, why don't we change it a little bit? Is that possible? So we can have like Brussels, or for me, Leuven. So the heart of Clojure place, Leuven. And then you're in Den Haag?
Yeah, The Hague or
The Hague.
Amsterdam. I think if you play Amsterdam music, Netherlands, weather is like going to be just rain. So it's going to be like a flat G
It'll be
or
interesting,
something.
It'll be interesting to see like a global algo.
That's true.
Is it easy to change or not?
No, that's not possible because
Okay.
this is the United States National Weather Service.
Oh, right. Okay. You're not
okay.
using Yahoo
Okay.
Weather or something. Yeah. Okay.
No, but
Yeah.
so you've got the New York is percussion, LA is an upright bass, St. Louis is a saxophone, and Durham is a vibraphone. So you end up with this like weird jazz based on weather
All
data.
right. Okay.
Right. Without further ado,
Yeah. Let's hit it. Yeah.
as the notes get lower, that's the weather getting colder. And the wind speed controls how fast the notes happen.
Okay.
And I don't know if we're getting stereo, we're probably not, but panning is controlled by the wind direction.
Okay.
Cute.
Oh, it's picking up again.
How long is the forecast for?
You get 150 hour chunks.
Oh, wow.
Anyway,
Okay.
I'll turn that off. We don't need to listen to the whole thing.
Well, it certainly makes weather forecasting, listening to weather forecast a bit more interesting than, we have at the moment. Yeah.
Right. Like a hurricane came through North Carolina as I was working on this. So I was like, let's see what the weather is like in North Carolina right now. And, as you might expect, is the notes were very fast and moving up and down.
Yeah.
The wind was all over the place.
And if you get a Sharpie, can you change the weather?
That's the next feature, Alda V2 or Alda V3. Draw your own hurricane.
Yeah. Sorry, that was off topic.
Political joke. So can you play the other one, the composition or
Yes.
So how complicated is this code, by the way? It should be pretty easy for a guy like me to write this code, right? To copy from the sheet music.
Yeah, so this is it's a string quartet by WC, so there's 4 instruments. The whole file, this is just an excerpt of it, but there's 53 lines. Each instrument part is like, maybe 10 lines or so.
Okay.
So it's very concise syntax.
This is in your GitHub repo, right? As an example somewhere, or
yeah, actually this example, if you go to it's GitHub Alda Lang Alda Core is the name of the repo.
Yeah.
There's a folder of examples, and this is one of them.
Perfect. Okay, let's hear it.
All right.
Very
That's the end of the
good.
excerpt.
Beautiful.
Very good. Yeah. This is a perfect medium, isn't it? Podcasting is a perfect medium for this kind of stuff. It's
Yeah.
but this is a first for Defen, where we have everything like done interactively and put music on live. So yeah, congratulations, Dave.
This is amazing.
Good first.
Thank you.
Thank you. Yeah.
Thanks, Dave. So good luck with Alda project, and hopefully you'll make more progress and then bring more Clojure into the rest of the components soon.
Yep.
So I think we are 1 hour 10 minutes already. That's nice. So thanks again, Dave, for showing up on the podcast on Sunday and then playing all this music for us.
Yeah.
And hopefully more and more people will try out Alda. And then I think you'll basically make most of the orchestra people's lives very difficult because they can add keeping. So if you want to make music, you don't need orchestra anymore. You can just have a computer and then you can just make it.
Yeah, let's take their jobs.
Amazing.
Yeah.
Yeah, exactly.
No, I think for me, it's like I like the fact that there are quite a lot of creative activities like this in Clojure. When we were at the Heart of Clojure, we saw one of the talks was by a lady who was doing random, well, not exactly random actually, but a sort of artistic generation of images, and you were doing the Alda stuff with the music. So, it seems like it's like the algorithmic or computer intersection of arts is becoming more viable, and obviously having more tools like the sort of stuff you're doing, Dave, is really useful for artists and for people who want to be artists or want to just experiment with things. So, I think it's really great, and thank you very much. And I think it's an inspiring activity that you're doing there. So, and I've got to say, I mean, it was such a pleasure meeting you in the Heart of Clojure. I mean, you're such a positive, delightful person, and that shows through on this podcast as well, I'm sure. So I really appreciate all the effort you've gone to, and just being an awesome dude. So cheers, mate.
Thanks a lot. It's been great being on your podcast.
Of course, and
of course,
not because we are.
Of course,
we
it's
are
been great.
Exactly.
Why wouldn't it be?
Totally.
I mean, he's great. I'm great. You're great. Oh yeah.
No. So what I meant to say was that, of course,
okay.
Whatever Ray said was completely true, and it was a pleasure meeting you at Heart of Clojure, and it's I like that you're working on a project for so long, and I can see how passionate you are about this stuff, and that's why when I saw you started Alda like 2012, I was like, wow, there are not many people. I mean, side projects are like every weekend, right? Like people start a side project and then it just disappears pretty quickly. But you're changing the architectural designs. You're making it even better, and it's the user experience is amazing. And I hope it's gonna get be very useful for people who are composing music, and then people who are using Clojure as well. So thanks a lot. Thank you for joining us on the podcast and playing the music. I'll certainly give it a try again more and more, and then try to understand the music better, I think. So
thanks a lot for having me.
It's an absolute pleasure, Dave. It really is a pleasure. Yeah. And I think Dave is a bit of an exception, isn't he? He's not a Patreon. Normally we have guests.
No, he's not. Yeah.
Yeah, we only have guests who are Patreons.
Oh, I gotta get on that.
So these days we only pick guests who are paying us. You need to pay to be on the podcast or something. but I think that's basically will reduce our Patreon to 2 people again. But one quick update is that we used to do the live shows, but these days I think because of the technical what do you call it, like the deprecation of the Google Hangouts thing, we are trying to figure out what is the best way. So but we'll see what we can do for our patrons, and we are going to have another episode recorded pretty soon, so keep listening. That's it from us for this episode number 53.
I think it's 54. I think it's 54.
Okay, 54.
Yeah. We'll work it out. Who gives a shit, to be honest, you know?
Exactly. Totally. Yeah.
It's episode Dave, you know. It's episode,
episode
Alda
Dave.
and Dave, and, you know, let's be more
And
humane
Debussy.
with our episodic indexing.
Exactly. Yeah. That's it. Thank you. And see you next time.
Cheers.
See ya.
Little did they know that it was, in fact, 53.